Hi, my name is Derek. I'm the president of Octane Workholding, and I want to show you how to install an optical tool setter as well as installing it onto our contact probe offsetter, which actually gets your tool setter off the edge of the table, allowing you to place additional vices, any type of work holding, any type of part, large parts, high density fixturing, anything of that nature. You really gain a lot of space, and you can actually get your tool setter off the edge.
Alright, so what we have here is just a standard ER collet check. I've got an extra long end mill here that I'm just putting in upside down. The shank on an end mill is ground extremely close to the nominal size, and it'll be good for what we're going to use here. This is going to be our tool that we actually do our calibration with. Just placing it in, and I'm going to torque it down lightly. Because we're going to be working so close to the edge of the table, a smaller tool gives us some extra travel, and that's why I selected 1/4 inch. I placed the tool holder in the spindle and checked the run out. This is a 10th indicator and there's almost no movement on the needle. We should be good here. If you already have a tool setter installed to your machine, now would be a good time to record the length of this calibration tool. At this point, I'm going to move to the side access door on the mill. It's going to make things a lot easier to set up.
Okay, so let's start with the installation. What we're going to start with, we have the base rail here that has 3 non-marring jack bolts. You see they're turned down, they're actually relieved so that nothing ever hangs up on the threads. And the way this works, when you slide the profile into your T-slot, this top base will obviously be mounted at that point, but when you tighten these down, you see it's actually lifting the profile up, and it actually traps underneath the wings of your T-slot here. And when all 3 of those start tightened down, it's going to be a very secure hold, way more than we're going to need for installing the optical tool setter. But what we're going to do here, I just want to show you kind of how this goes together. We have a couple different configurations which allows you to place your contact probe offsetter on any corner of the table that you want or any slot. You have the nice engraving on here, and we have a really nice fit in the middle configuration so that when everything's tightened down, you're very close to square and perpendicular, parallel. Everything's nice with the table, so you don't have to do a whole lot of alignment. But we've got a really nice fit in there. It's hardly any play. And then we have a left and a right configuration. So in one of these side configurations, your supplied hardware, these are actually 3/8 bolts, will go through and they'll tighten down in this direction, right? And it's just the opposite as you put it on the other side. Trying to get the camera to focus for us. There we go. All right, you drop them in this side. Everything's a little harder working around the camera, but you can see how that plugs together, right? But what you've got here, if your machine can jog to the edge of the table, but you really can't go much beyond at all, there's actually a 3/8 inch milled relief on the back here. And what that allows you to do is in the middle configuration, you get 3/8 of an inch further into your table. That's going to add with that's going to aid in calibration if you need just a little bit of extra travel. May not be necessary for your machine, but I'm actually going to utilize it here just so that I can use a larger diameter tool. If you think about the size of your calibration tool, a larger tool means that you're going to have to over travel further. When you're looking at your tool setter, when we're standing in the operator position, I'm going to end up looking at it like this. If you have, say, a 3/4 inch end mill, you're going to have to go past your table edge by a long ways. The smaller tool you use, the less you have to travel. So what does that mean? You could go down to an 1/8 inch diameter tool. As long as you know the diameter of that tool, you can use whatever size tool you want, which means your over travel amount can be far less. We've actually got a 1/4 inch tool loaded in the spindle, but let's move forward here. I've got an assembled one here, and I'm just going to slide it into place. Until it seats up against the edge of the table. You could put a little bit of rust preventative in here if you wanted to, but I'm not worried about it because everything's black oxide finished and you shouldn't have any problems with corrosion. Tighten these 3 down. As I'm tightening these, it's lifting the entire profile up, and it's not going to take a lot of torque. I'm just going to put a little bit of pressure down. Snug, snug, and snug. And you would pretty much be able to tap this with a hammer at this point. That's a very solid base. You have 1 inch of profile here in Z, and everything here is especially backed up in this configuration up against the table. It's like a springboard that's not allowed to drop. It's a very solid base. Okay, let's move forward. Okay, so I've actually changed my configuration. I had it mounted to the side. So here's a good example of what to do when you're measuring your bolt. If you actually put your assembly together, if you were just going from the base of the tool setter and not having a riser, you would want to look at this distance below, and you want to make sure that it's not greater than the distance from the top surface of our base down to the T-slot rail. So if you actually look at that here, it looks like I need to trim roughly 1/2 inch off this in order for this bolt not to bottom out on the T-slot rail. So I'm going to do that and we'll be right back. Alright, we're back. I have shortened the bolt. We're going to drop it in. Everything should go a little smoother this time. Find that tap tool, run this down. We check everything with our contact probe offsetter with thread gauges. This thread feels slightly snug, but I would probably blame the bolt, not the contact probe offsetter, because I checked it myself. So I'm just feeling that feels like we're about centered in the travel, swinging my logo over where I want it. Just going to look at that from the side on the riser here. Again, you may or not need this, may or may not need it for your machine. I just like to have mine looking nice. I use stainless steel, and I'm going to snug this down when the actual optical tool setter base is in line with one of my axes. I'm actually going to use X here because I'm going to actually mount my tool setter in this configuration. What that allows me to do, I can touch off basically any diameter tool from that side of the travel. I can use a 50-inch diameter tool if it existed, right? You have infinite space left of the stylus on here. So I'm just lining this up with X, and I'm going to slowly snug this down and give it a little bit of torque. Don't want it moving later on. Everything feels good. We're going to do one more check on those 7/16 14 non-marring jack bolts that are in the profile, because I always do things twice when they're this critical. You really don't want this thing moving down the road on you. So, what's next? Let's make sure everything's really clean. Reach past here, grab a rag. I'm looking up inside here, and we've got a little bit of debris inside. Let's see if we can get that a little cleaner. A little bit of lint, that's not going to hurt anything here. You might blow that out, because as a machinist it pays to be really meticulous a lot of times, especially on something important like this. Once we set this, we want to leave it there forever, if possible. I have the air turned off, so I'm not making so much noise. Sorry about that. Okay, it looks pretty clean. I'm just manually wiping the lint out of here. Everything's impromptu. I'm a real machinist. Everything I do is not scripted, so as you see it here, you're getting it live. So we're gonna actually place this on. Again, you could put some sort of rust preventative in here. You could just use a light grease, or even a lightweight oil will help with keeping everything nice and clean in there. But I'm not too worried about it, because everything below the base is stainless steel in my case. So at this point, everything, you see there's actually this taper here, and then you just have set screws inside. Give you a close-up of that. There's 1, 2, 3, and there's a 4th one up here, right? And then there's actually a little pin over here on the right side that is encapsulated with these 2 set screws here. That's kind of the anti-rotation one that puts you into alignment. So we'll drop this on carefully. This is not a cheap tool. We want to treat it with respect. And I'm just going to hold that down. And we got our small Allen wrench that was supplied with the tool setter itself when we purchased it. Or at least it should have come in the kit. Just looking at everything. Okay, there we dropped on. I was wondering what was holding up there. So now I'm just starting to slowly tighten these down. And it's not critical that you get this perfectly in alignment. You can put an indicator on here and actually get this perfect, but I'm not too worried about it. I'm just going to eyeball it really close in line with X. And then I'm going to snug down all 4 corners. What do you think? Looks pretty straight? It's hard to tell from your angle. Okay, so what we're going to do now is we're going to actually rotate this base. We've kind of got a flexure here on the bottom with their setup, and we're going to align X and Y so that that stylus is very close to perpendicular with the spindle and parallel with the table. I've got a Noga base up here. I'm just sticking this fast to the spindle. Turn the magnet on. Make sure it's nice solid connection, and then I've got a 10th Mitutoyo indicator here, and we're going to put it as close to parallel with the top of the stylus as possible. But all we're doing is I'm going to start with one direction. Go into Y. And we're going to go across on Y from one side to the other. So there, I'm a bit above the 4, and on the extreme opposite, I'm a bit above the 4. And if you look at the book here, it looks like the 2 on the base are going to get you on the X-axis, to and from, right? And the 2 at the top here are going to get you on the Y-axis, so away like that. So what we're going to do, find the one that fits. We are working on Y, so we're going to adjust these. We're going to make very small movements. Find the Allen wrench that fits the bottom. Stop that one. We're just going to place it there because we'll get to that. Okay, so the goal is to get no movement from side to side, front to back, basically in a cross shape. We're on 4, both sides on Y, that looks good. We've got that little low spot in the middle, but we're not too worried about that. 4 and 4. You want to get this as good as you can, but really it's not as critical as you might think. It's not going to affect your tool length all that much. If you're really doing precision work, you want to spend a little bit more time on this. So there it is, and let's just show you the setup here from a distance. You see I'm just stuck fast to the spindle there, and I'm actually doing my adjustment on, if you look at the manual here, we're looking at our Y-axis adjustment is the ones here you see on top. So when you tighten one, it's going to offset the other basically, and then you're doing your X adjustment to and from like this, knotting with your one down, with the Allen wrench down here, like you see in your manual. It's really not hard, but it might take you a little bit to get it the first time. Alright, so like I said earlier in the video, what you're going to want to do is actually touch this tool off that you're going to use for calibration on the tool setter before you remove it. But if you accidentally removed it first, it's no big deal. I'll show you how to touch off the tool manually. We're doing nothing with changing your actual probe. I'm sure you have a probe if you have a tool setter. That's all still in the spindle, everything's fine. Just come down and get your G54 on the top of a known length object, like a 1, 2, 3 block. And that one, what we'll actually do is we'll jog past on Z, below the block, and then we're going to come up 1, 2, 3, 4, 5 thousandths until the block slides under. We're not going down, we're going up with the spindle. We just slid under. Let's go back down 1 thousandths, and it's snug. Let's go down one more, and I cannot get under. Now what I'm going to do here is I'm switching to 1/10. We're still on Z, and I'll show you here. I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths, 1 thousandths. There, we just slipped under, and everything's sliding underneath. Nice. Let's go down 1/10. We cannot get under, so we know that's our length right here. So then what we're going to do is we're going to take that offset, and what we're going to look at is our offset work. When we set our G54 here, it was negative 30.4132. So we're going to enter that 30.4132 into your calculator, and then just subtract the machine position 25. So it's 30.4132 minus 25.5089. Then we'll go over to our offset. Everything's hard to throw camera, I apologize. And our actual length is 4.9043. So that will actually be automatically pulled into our calibration routine since we set it here as an offset. So then what we're going to do is we're going to actually get a tape measure, and if this passes the sniff test, we're going to go from the gauge line, right? This is a dual contact machine, down to that block. Does it look like 4.9? Yes, it does. So I'm happy with that. I trust it. And we're going to move on to the actual length calibration on the tool setter. Let's do it. Alright, so as you can see here, we've got a 1/4 inch tool inside the spindle, and we are clearly past the stylus by a good bit. That looks like it's close to maybe half, almost 5/8 of an inch of over travel. The smaller tool you use, the further you can go, right? If we're using a 1/2 inch tool, we would not have quite as much travel, and we might not be able to get our diameter calibration pulled off. So all I'm doing is I'm using a tool of a known diameter, right? And we're gonna find the length. So what I'm gonna do to start here, you can see my machine will actually jog right to the edge on X. We're at 0, right off the edge. So what I'm gonna do is I'm gonna grab my remote jog handle here, and we're going to align as closely as we can, gotta press handle over there, with the center of the stylus. So we're just gonna do on X, and then we're gonna go on Y, and then I'll show you what we're gonna do here in a second. Alright, so we're ready to do a calibration. Let's go in there to Edit, to UI. Let's go to configuration first. And as long as you didn't change anything, we're going to press MDI. If you're on a different machine, things might be slightly different, but I'm on a Doosan here. We're going to go to tool setter, and stylus diameter is the same. I have not actually changed the physical orientation of the tool setter, so I'm going to leave everything the same. I'm going to press next. Everything here looks the same. What does change is I'm going to go down here to edit, and we're looking at the short tool, long tool. This was 14 inches, which was the max length tool that I was using to actually touch off with. And what actually happened here is we lost about ½ inch by being in the middle configuration. It's not quite ½ inch, but I could compensate from that by actually shortening my riser here. If you're actually right on the base itself, you are going to lose ½ inch, which hopefully that's not the end of the world for you, but it's one of those things where I could compensate for it, but it doesn't really affect me because I'm rarely using the full Z travel of this massive machine. So I've actually taken that 14 and changed it to 13.5. If you're in one of the left or right configurations and you don't actually need so much over travel, you can actually gain some Z travel, which is nice. So I'm going to confirm everything's good there. And we're going to come back here to calibrate. And we're going to do a tool setter calibration. We're going to let it run the full calibration, full master tool. We've already set the length. We're going to say the tool diameter is 0.25. If you come up with the calibration and you're not getting exactly what you want to see here, just lie to it. If you're getting a 1/1000th discrepancy, say it's a 0.251 tool. All you have to do is lie to it, and you can really use any tool. As long as you don't have any run out in the tool itself, you can just trick it by entering whatever you need to see what you need to see with your actual results. So we're using tool 29, we got our length, we got our tool diameter. I'm going to press memory, and we're going to hit cycle start twice.
Alright, now it's going to go through its little calibration routine. It's going to touch off length first, and then it's going to touch in 3 places for diameter. And once it's done, we should be all calibrated. Okay, now you're all set to touch off tools as you normally would. As you can see here, you could actually slide a vise right up next to your tool setter in the corner of your table if you wanted to. You can place large fixtures or anything that you really need to utilize your entire table. You can do that now. That's really the beauty of the Contact Probe Offsetter, and I hope you found this video informative, and if you have any questions, feel free to ask. Please like, share, and subscribe, and if you follow us on Instagram, we post daily tips and tricks aimed at making your life easier.